So let us look at the coordinate geometry problem that was requested by Mr. Rahul. So the problem first defines what are concyclic points. So concyclic points are defined as the points A, B, C, and D if they lie on a circle. So if the points A, B, C, and D they are lying on a same circle, then they are called as concyclic points. That's it. But the problem starts now. It says we have to prove that if the line a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 meet the coordinate axes in 4 distinct points which are concyclic, then you have to prove that a1, a2 equals b1, b2. Then you also have to find the equation of the circle which is passing through these points a, b, c, and d. So let us first assume how this problem will look like. So the coordinate axis I have drawn, this is x-axis, this is y-axis, this I assume is the first line, and this might be, say, second line. These 4 points are there. We are given that these 4 are concyclic points, so a circle might exist like this one. So if these 4 points are lying on a circle, then I have to prove that this is the equation of the circle given over here. And I also have to prove a1, a2 equals b1, b2. So one way to do it is, let us assume the general equation of a circle, which is x minus a whole squared plus y minus b whole squared is equal to r squared. So what are a and b? A and b is the center of this circle, and what is r? R is the distance between this point and any point on the circle. So I will have to compute a, I will have to compute b, I will have to compute r, and then I will be able to derive the equation of the circle. So how will I get a, b, and r? I will know these 4 points where these lines are intersecting, x-axis and y-axis. I will substitute them in this equation. I will find out these points by putting x0 and then y0. I will get these 4 points. I'll put them over here. I'll be able to solve for a, b, and r. Then I will get this equation. And meanwhile, while I'm trying to find the equation of circle, we will also be able to prove this. But that is a really long process. There is another way we can do it. That is, if there are two curves S1 and S2, and S1 and S2 are intersecting at some point, and there is another curve S3 which is passing through the points of intersection of S1 and S2, then S3 is equal to S1 plus lambda S2. So how do I compute S3 then? See, lambda is a variable. We can compute lambda, but because there will be some conditions imposed on S3. Say I have a circle S1, I have another circle S2. Now there is another curve or circle, or say S3, another curve which is passing through these points which are intersection of S1 and S2. So this is S3. We will be given certain conditions like, say, this is the center of S3 or this is the radius of S3. So I will find out the radius of S3 in terms of lambda, and then radius will be given to us, and from there I will be able to compute lambda. So I will try to implement something similar over here. So I have given curve S1 as a pair of equations. So pair of straight lines can also be written in this form as a curve. So which is nothing but this, a1x plus b1y plus c1 into a2x plus b2y plus c2. Okay, so this is my S1, which is a pair of straight lines, which are these two equations, a1x plus b1y plus c1 equals to 0, and a2x plus b2y plus c2 equals to 0. But then what will be my S2? Okay, x-axis and y-axis are also straight lines, and I can also write curve S2 as well, something like I have done for S1. So what will be S2? See, x-axis and y-axis perpendicular to each other. On x-axis, the value of the y coordinate is always 0. This point may be minus 2, 0. This point may be 0, comma 0. This point may be 2, comma 0. So the value of y coordinate on all the points which are lying on x-axis are 0. So in a way, x-axis can be represented by a line y equals to 0, and y-axis can be represented similarly as x equal to 0. Since I am saying curve S2 is a pair of straight line which consists of coordinate axes, I can write S2 as xy. Xy equals to 0 represent x-axis and y-axis, because the solution for xy equals to 0 is either x equals to 0 or y is equal to 0, and x equals to 0 represents y-axis and y is equals to 0 represents x-axis. So I can write curve S3 as S1 plus lambda S2, where S1 represents a pair of straight lines which are given by this a1x plus b1y plus c1 and a2x plus b2y plus c2, and curve S2 is xy. So S3 is nothing but a1x plus b1y plus c1 into a2x plus b2y plus c2. And what is S2? S2 is just xy. So this will be my curve S3, which is passing through the points of intersection of these two straight lines with coordinate axis, which is x-axis and y-axis. Now, how do I find out lambda? We can find out lambda as these points A, B, C, and D are lying on a circle. Okay, so S3 is a circle. So we will use the properties of circle to find out lambda. If we have seen the general equations of a circle, you will notice that xy term is never there. Xy is absent. Why? Because the general equation of a curve is given by this. For x minus a whole square plus y minus b whole square is equals to r square, you will get x square terms, you will get constant term, you will get x term, you will get y square term, you will get y term, you will get constant, and this is also a constant, but there is no xy term. And I can use that fact that xy term is absent to find out the value of my lambda. So I will just expand this bracket to get the lambda, to get the xy term. So I will get a1 a2 x square plus a1 b2 xy plus a1 c2 x. I will also get a2 b1 xy plus b1 b2 y square plus b1 c2 y. Then I will also get, when I multiply c1 with this, is a2 c1x, a2 c1x plus b2 c1y plus c1 c2. Now notice we also had lambda xy here, so I will write lambda xy. So let us try to reorganize this. S3 is equals to a1 a 2x square plus, let us put x terms here, a1 c2x plus, where's the other x term here, a2 c1x. Now let us put the y terms here. So b1 b2 y square what will be the y terms? This one and this one. So b1 c2y plus b2 c1y. Now let us put the xy term. Where's the xy term? This one and this one. So a1 b2 plus a2 b1 and this one is also there, xy term. So plus lambda into xy. There's a constant term as well, c1 c2, let us not forget. So this is S3. Now we will use the properties of a circle to find out our lambda. In equation of a circle, there is no xy term, hence the coefficient, which is this, has to be equal to 0. Since S3 is a circle, we can write a1 b2 plus a2 b1 plus lambda is equal to 0. So lambda is equal to minus of a1 b2 plus a2 b1. So we are done. We have find out the value of lambda. So we have S3. So we can write S3, that is the equation of the circle which is passing through the four concyclic points, which are the points of intersection of two lines, a1x plus b1y plus c1 equals to 0 and a2x plus b2y plus c2 equals to 0 with coordinate axis. A is given by a1x plus b1y plus c1 into a2x plus b2y plus c2 plus lambda xy. What is the value of lambda? Lambda is here minus a1 b2 plus a2 b1. So this is my equation of the circle, hence proved, which was part 2 of the problem. So we are done with this one. Now we have to prove a1 a2 equals to b1 b2. Let us examine the equation S3 again. So this was S3, the expanded form. Okay. Now notice that when I wrote the general equation of a circle, it is of this form: x minus a whole square plus y minus b whole square equals to r square. So when you expand it, you get x square here and y square here. The coefficient of x square and y square are equal, which is 1. If the coefficients of x square and y square are not equal to 1, you will not get a circle, you will get an ellipse. But we do not have an ellipse, we have a circle because these points are concyclic, not co-elliptical. These are concyclic. That is, they lie on a circle. Hence, the coefficients of x square and y square have to be equal. They have to be equal. Since S3 is a circle, coefficients of x square and y square are equal. So what will you get? You will get a1 a2 equals to b1 b2. Hence proof for part 1 as well. So now that you have the equation of the circle, which is given by this, you can easily compute the center of the circle and you can compute the radius of the circle. You can use the expanded form, put this equal to 0, complete the whole squares, and you have your answer. So I hope this was enough. Okay, let us end the video.